Hello, everyone, welcome to watch this video. In this video we will introduce the CAM advanced settings. The content includes 8 parts, from setup, geometry to the machine, output settings. Let's check one by one. In the CAM Manager, on the top we can find Setup. It is to set the item's visibility in CAM Manager. Just right-click on Setup node, and then click Settings from the shortcut menu. For example, we can tick the checkbox of minimum under the tool to make the tool minimum length be shown in the operation. We can get the minimum tool length value by clicking Check Shortest Tool from the right-click menu of operation. There are some notes here. First, only 3-axis operations can check shortest tool. Second, we need to define the tool holder. Last is we need to right-click Check Shortest Tool after calculation. If toolpath is already there, just click the feature to get the value. You can show or hide more items of CAM Manager, such as total time. Next to setup is geometry. This is to manage all the geometries in CAM environment, such as part, stock, table, clamp, and so on. From right-click menu on geometry we can find all the functions. It is very easy to understand. For example, we can click Insert Component to insert the external stocks, add some auxiliary surfaces for 3-axis or 5-axis machining. If the file is Z3 file, you can find all objects in the Shapes tab. Select the one you need to insert. If we right-click on the specific geometry, the menu is different. From here, we can change the display mode, create new feature for the geometry, or edit the class type. Please note that the default class of the inserted component is part. We need use edit class to change its class accordingly. If we add feature based on the specific component, only the specific component will be displayed for your selection. For the feature, we can select it and click Assign to All to add the feature for all existing operations. We can also find there are some other functions from the corresponding right-click menu, such as rename the feature and so on. Please note that the right-click menu are different on different level. As we all know, ZW3D is an all-in-one CAD/CAM solution. It is very convenient to modify the geometry during the toolpath programming process. Just double-click the geometry to switch to the CAD module to make the modification. After that, we may find that there will be an exclamation mark on the icon before the geometry name. We can click Update Status to update the geometry, so the icon will disappear. We can also choose to update operations to recalculate all toolpath. Next we can find the Clearances node. It is to set the default global clearance Z for all new frames. Just double-click this node and set Clear Z value. This is called Global Clear Z, and there are 2 places for Local Clear Z. One is in the frame. It will be inherited from the global value by default for new frames. The Clearance Z in the new operation will be inherited the value from its frame. For the existing operation, if you reselect the frame, the value will be overwritten, so please check it if you don't want it to be the same as it in the frame. In the following it is frame nodes. By default, there is only world frame, but in most cases, we need to create local frame for toolpath creation and output. We can double-click or right-click it to insert new frame, and we can also control the visibility of the frames and datums from right-click menu. When we create a new frame, we can use the option Fixture Offset to specify the machine frame for the multi-stations machining. Let's explain it in next page. As you can see here, we want to machine this electrode part in batch. In CAM, we just need to insert one part and create auxiliary surfaces. Then we define the features based on the auxiliary surfaces. After that, we need to create frames for each station. During the frame creation, tick Fixture Offset and set the offset register as auto or specific value. The list needs to be defined in the Machine Manager. If it is set auto, it will use the offset register value according to the frame creation order. Then duplicate the operation and specify the frame and feature and recalculate. To output the correct NC code, we need set the toolpath space as local. There is another way to do the multi-station machining, which is using the station setting in the output setting. With this way, there is no need to set the offset register's range in the Machine Manager, and we need to untick the fixture offset in the frame. As you can see here, just create the first toolpath, and then tick the station setting in the output setting, and add the station information, and set more settings if necessary, then output directly. Let's check all above settings in software directly. First, check Setup. Right-click on it, then Settings. Tick the minimum under the tool, OK. We can see the minimum is shown in the operation. Go to Tool Manager, define the holder. Click OK. Recalculate. Right-click Operation, click Check Shortest Tool. We can see the minimum value now. In Geometry, we can insert component. For Z3 file, all objects are listed here. Choose the one we need. Click OK. The class is part. Right-click to change the class to stock. Choose specific geometry. We can change the display mode. Add new feature surface. You can find it only display the current selected geometry. Choose the face, and finish. For feature, click Assign to All. It will be added into all existing operations. Here we just demoed the feature Assign to All. To calculate the right toolpath, we need to delete the wrong features. And then calculate all. Next is clearances. Double-click it, modify the value to 50. Insert a new frame. The value is 52. To prepare the multi-station machining, here we create frame 1 with 50 offset for the second station. And frame 2. With 100 offset for the third station. Duplicate the toolpath. Create the third surface feature. We can see the clearance Z in the operation is 100. Here we modify the frame to frame 1. The value will be changed to 50, which is from frame 1. Specify the frame as frame 2. Change the feature to surface 3. Calculate. Now let's check the multi-station machining. First, go to Machine Manager, set offset registers as 53 to 59. Then set it in the frame. Calculate all. Output NC. We can go to the NC setting to set the toolpath space as local. The reason why we set the toolpath space as local is that we will use the frame in each station to machine, so we need the NC output coordinate values is based on each frame. If we set it as machine, all the coordinates will based on the machine frame. We can find there are G53, G54, G55. Let's check the second way to set the multi-station machining. Untick the fixture offset in the frame. Recalculate the toolpath. Go to Machine Manager to remove the offset registers. Click the first operation and output it to NC. Go to NC setting. Tick Station Setting. Add the station information. Set other information if necessary. Output the NC. This way is much easier, which is also we recommend. Just use the first station toolpath and set it in output setting. We can find it also outputs the G53, G54, G55. Now let's check the tool manager. We can create different kinds of tools in ZW3D, including milling tools, drilling tools, and also turning tools. Turning tools will be introduced in the turning module. As you can see here, this table shows the commonly used milling tools. You can find the usage, key parameters, and shape. And the same for drilling tools. Besides the tool shape definition, we can set the tool ID, D register, which is for tool compensation on XY plane, H register, which is the tool compensation on Z direction, and more parameters such as coolant type, spindle direction. Pre-operation and pre-tool are used to create the tool library for the whole tactics. You can refer to the video about drilling module for further explanation. Please note, in the Shape tab, Add to Lib just adds the tool shape into the tool library and save all add settings in all tabs into the tool library, while it is same for Load All. Normally we need to click Save All to build our tool library and Load All to load all the tool information from the tool library. Next tab is used to define the tool holder. We can load tool holder from the tool library or define a new one and save to the tool library. Please click Apply after you load or create a new holder, which can ensure that when you switch to other tabs, the tool image will be updated with the new holder. In Speed Feed tab, we can set a group of speed feed value for the tool. After that, we can load it in the Operation Parameters window. Sometimes we need to create a custom tool to machine the special feature. So how to create a custom tool? The steps are listed here. First, we need to create the profile of the custom tool and make dimensions. Then we need open the tool manager. Choose the subtype as user define. Follow the dimensions to create the custom milling tool. The key parameters are the LL and LA. LL is the line length for each line section, and the LA is the line angle with the horizontal line. If necessary, we can also set the AR and AS parameters. Let's just go to the Machine Manager to check out directly. Double-click Tools to load the tool manager. Give the tool name. Modify the tool shape. Go to Second tab to set Tool ID and so on. Third tab to set Tool Holder. Click Apply to update the tool image for all tabs. And the last tab to set speed feed values, add one more. Click Save All to save it into the tool library. Let's try to load it from Tool Library. Go to the Tool Manager again, click Load All. Find the newly added tool D8R0. Load it. All information are loaded. Please note the Add to Lib and Load Tool Shape is only for shape info. The same for add to lib and load holder is only for holder info here. Now let's check how to load the speed feed value in the operation. Double-click the operation. Specify the new tool. Click Speeds Feeds button. Then copy values from tool and choose one to load. Now let's check how to create a custom tool. To machine such part, we may need a special tool to machine this place. First, we need to draw the custom tool profile. Let's check it in the part. Here you can see the tool shape and dimensions. We can see each line section length and angle. Go back to CAM workspace. We find there is exclamation icon on the geometry icon. Just click Update Status in the right menu to update it. Open the Tool Manager. Choose Subtype as User Define. Add each line section with the length and angle. Finish the creation. Use the new tool and recalculate. Verify to check the tool shape. Then solid verify to check the final result. Till now we are quite clear about how to create and manage the tools in ZW3D. However, for the user who upgraded from the previous versions, maybe they have already built their own tool library in Z3 file. How to convert it to our new tool library form? It is very easy but a little bit hidden. We can open the Z3 tool library file in ZW3D 2024 and then run a special command in the command line at the right bottom corner. It will generate a new Excel tool library file for each CAM object inside the Z3 file. The files will be put in the same folder as the Z3 file. After that, we can copy it to our default tool library folder under the installation folder. Then we can load it from there in the tool manager. To make this converter more visible, we can follow the steps here to customize it in the ribbon. So next time we can just convert it by one single click. No need to remember the command anymore. After we finish all the toolpath creation, we also need to output the whole operation view for check whether everything are correctly set. Just right-click Operations node, click the operation view to get it. We can check all the parameters and we can also customize which columns need to be displayed and its display order. Just click the item config to configure it. If necessary, we can also modify the parameters here and save to the operation by Save All and update the toolpaths by Calculate All. We can also go to Feature View from here. All the toolpaths seem fine after check. Then we need to specify the machine for NC output. Let's check the machine manager. The most important setting is to specify the post files, including the ZNC file and MDF file. We can also control whether output arc move for the arcs on different planes, spatial arc or helical arc. Please note, currently, the XYYZXZ arcs are based on the machine frame. Normally, the check multax is set yes, and the multax is no. If you set Multax as yes, then it will turn on the Multax in CL, which will output the XYZIJK value. Normally it needs to be turned on for 4 to 5 axis toolpaths, including the indexing machining, while no need for the 2 to 3 axis machining. The other two options are quite easy to understand. One is to define how many digits for the decimal number of coordinate to be output in CL, and the other is to set the file extension of NC file. There is one more option which needs to be explained a little bit, which is accurate rapids in Machine Manager. It is used to control whether turn on or off the following message display. Let's check when it will pop up. The first condition is that we have to set the traversal speed as rapid. If there is some traversal toolpath as shown in the picture, then if we set this option as no in the Machine Manager, the default value, and when we calculate from the Operation Parameters window, the message will pop up. If the machine does support the accurate rapid traversal, then we can just set accurate rapids as yes in the Machine Manager. The message will not pop up. If the machine doesn't support the accurate rapid traversal, it will not follow the exact traversal toolpath. The message will pop up to warn us, and we can follow the message to click yes to set safe rapid traversal as yes, which will update the toolpath as safe 1. Let's check in ZW3D directly. First, let's check how to convert the old tool library. Open the Z3 tool library file. Copy the command from slide and paste in the command line. We can see the conversion succeed. Let's check in the folder. There are 2 Excel files. Copy and paste them into the default tool library folder. Let's try to load it in the Tool Manager. Click Load All, load the tool library file. We can check all the tools inside it. Next, let's check the Operation View. Right-click on the Operations node, click Operation View. Click Item Config to make the configuration. Set columns show or not. Adjust the order. Click Save button to apply the modification. Check the parameters such as speed, adjust it, and click Save All to apply the modification into operations, and calculate all to update the toolpath info if necessary. We can go to Feature View from here too, and go back. Now let's check the Machine Manager. Double-click the machine node or existing machine to open the Machine Manager. Let's check the options inside. Specify the post file and MDF file. And control the arc move output or not. Only we set Multax as yes, then the spatial arc will be available. Set the NC extension as ISO. And set the coordinate precision as 3. Output NC. We can see it is nc.iso. Output CL. We can find there are 3 decimal digits for coordinate value. Next, we need a sample to show you the option Accurate Rapids option in the Machine Manager. First, we need to set the traversal feed as rapid. When we calculate, there is a warning message popping out. As we can see, there is a traversal toolpath which is in light blue color. If the machine support it, open the Machine Manager and set the accurate rapids as yes. Then no warning message pops up again. If the machine doesn't support it, then set it as no. We can follow the message to click Yes to turn on the Safe Rapid Traversal in Advanced tab. The transversal toolpath will be divided into two segments, which is much safer. After we define machine, the last step is to output. We can output the NC file and also the shop document. For the NC output, we can do many settings, like we can select the machine, set the part ID, programmer, and output file location and name. The most important one here is the output frame. Normally, we can just keep it by default, or we can set the toolpath space to a specific frame, then the output coordinate will use this frame. If it is indexing machining and it supports G68.2, we need set the toolpath space as local, and the relation frame as a specific frame, such as machine or any custom frame. As you can see here, there will be two extra lines in CL, which can be translated by the post file to output the correct NC code. In the shop document output, we can output the operation list and also the tool list. One output document for once. The operation can be output as Excel file or HTML file. We can set it from the right-click menu on Output node. Here I would like to let you know the rules we need to obey for the template customization. First, all the keywords used in the template need to be inside the definition file. You can find them from this location. Second, it must include the keyword scan number in the template. Please make sure, do not delete it. You can change its location, but don't delete it. Last is do not change the sheet name default. As long as you obey above 3 rules, you can make your own template style as you like. Let's go software to have a check. Here is a sample to show you NC output. As you can see here, 2 operations on different frames. We have set 2 machines here, one is for 4x output. And another is for 5x output with G68.2. Let's check the NC output setting. First we can select the machine. Here select machine 1, which is 4x post. Set the part ID, programmer. Set machine as the toolpath space. Output CL. There is a line of origin info before rapid move. Output NC. It outputs the A value. Check the machine 2, which is 5x with G68.2 post, which supposes the machine supports G68.2. We need to set the toolpath space as local and set the relation frame. Output CL. We can see there are origin and rel frame lines before rapid move. Let's check the post. We need to open the G68.2 output as shown here. Output NC. We can see there are G68.2 and related code. Let's check a 5x sample. To output the correct NC, we need to set the 5x post file and set the multax as yes. Then just use the machine or specific frame as the toolpath space. Then output the NC. We can find that there are XYZAC output in the NC file. The last one is about shop document setting. Right-click Output node, click Shop document setting. We can choose Output Operation List or Tool List. For Operation List, we can choose HTML template or Excel template. Click Output Shop document. Here it is, the operation list in Excel. Let's check where is the template. In the CAM template folder, under the corresponding language directory, we can find all template files and the keyword file. The keywords we add in the template must be in this list. To modify the template, we must not delete the first column. And we cannot rename the sheet name default. As long as we obey these 3 points, we can do what we want to customize the template. For example, we delete the operation name column and save it as custom in the desktop. Drag it to the CAM template folder. Set it as the operation list output template. And output the operation list. We can find there is no operation name column now. That's all for this video. Thanks for watching.